Hello everyone, my name is Shelley Calhoun-Jones and I'm a Principal Technologist at Cohesity. In this video, we'll talk about how you can elevate your data resilience strategy with DR replication and archiving to Amazon S3. Let's get started. The Data Protect dashboard provides a unified view of your environment, and you'll notice that you can use these widgets to determine health, protection status, compliance, consumption, and more. And you'll notice up here at the top left-hand corner of the screen, we have the ability to select different clusters for redundancy and high availability. Right now, we're filtering by the Cohesity demo cluster, which you can see up here at the top. Cohesity supports the 3-2-1 backup method by providing scalable and secure storage for long-term data retention. For example, your organization may need to retain data for up to 10 years. And this often requires not only archiving backups to one cloud, but multiple clouds as well. In this example, we have two external targets for long-term archiving. You can always add more by clicking on Add External Target up at the top of the screen. Now, let's click on the AWS option and see how this works. In this example, we're archiving data to Amazon S3 for long-term retention. We've selected our Amazon S3 storage class and the AWS region. In this example, we're using incremental backups with periodic full backups. However, when archived data is retrieved, it's presented as a complete backup, containing all of the necessary information up to that point. And you'll notice that there are additional options available in the drop-down menu. And we also have the ability to set our encryption. One of the great features of Cohesity is that you can either choose an internal KMS or your own external KMS server for encryption. Other options on the screen include compression, source deduplication, and bandwidth throttling. Cohesity requires an Amazon S3 bucket and an IAM access key ID to archive data. The S3 bucket serves as the destination for your archive data. It provides scalable and durable storage needed to securely retain backups and archives in the cloud. The IAM access key ID is part of the credentials for an IAM user. In this example, we have a specific IAM user for Cohesity with tailored IAM policies. The policies are configured so that Cohesity will only perform the actions it is authorized to do using the principle of least privilege. Let's dive a little deeper and examine how this would work within a Cohesity protection policy. In Cohesity Data Protect, a protection policy is a reusable collection of settings, which defines the how and when for when objects from a source are protected. And you can create as many policies as you need for your use cases. Let's take a look at the Cloud, Archive, and Replication policy. In this example, we're utilizing the 3-2-1 backup approach. Backups happen once daily, but if needed, I could select a more frequent backup interval, such as every minute, especially for mission-critical workloads. In this example, we retain backups on the local Cohesity cluster for up to 2 weeks, and we also replicate these backups to a disaster recovery cluster for added redundancy. For example, if there's an outage in one of my data centers and I can't access the local Cohesity cluster, I could use the DR cluster if I needed to recover a workload. Additionally, we can also archive backups to AWS for long-term storage. And if we needed to, we could also recover from Amazon S3. You can see there are some additional settings on the right-hand side of the screen. There is also an option up here at the top for data lock. Cohesity Data Lock makes backups immutable, helping to protect against malicious actors who might attempt to delete them. Now let's click Cancel and examine a protection group which uses this protection policy. The protection group page shows you backup activity, an audit trail, storage consumption, and trends for the workloads that you're backing up. Protection groups allow you to quantify the types of workloads you're backing up, including whether they are mission critical. In this example, you can see that we're not only meeting our SLAs, but we're also saving the backups to the local Cohesity cluster, the DR cluster, and archiving them to Amazon S3. Let's click on the latest entry. In this example, I can see that the objects are backed up in the run details, and there's also a tab for each repository. If I click on a different tab, like replication, it'll provide a status of the activity, including whether replication succeeded. If I click on the Cloud Archive tab, it'll show the amount of data sent to Amazon S3. If I click on the backup activity, it'll provide a timeline view of the protection job, which is helpful if I need to troubleshoot something or just want to know more of what's happening behind the scenes. Earlier I mentioned that you could recover from the local Cohesity cluster, a cluster that you're replicating to, or from the Amazon S3 bucket that you're archiving to. Let's take a look at how this would work by doing a recovery. We'll choose our protection group, and then we'll choose to recover from the cloud. If this is a new configuration, I could choose to recover to a new location to test the recovery process. I'll select this option in the corresponding settings that I want to recover to. We'll keep it with instant recovery, and I'll also add a prefix for housekeeping purposes. We'll also provide a name for the task. Then we'll choose recover. In the recovery task, I can see the recovery from Amazon S3. I can monitor from here or click on Show Subtask if I want to get more information of what's happening behind the scenes. This completes the demonstration. We took a look at how we can elevate our data resilience strategy by backing up to a local Cohesity cluster, using replication, and archiving our backups to Amazon S3. We also performed a recovery from the cloud. Thanks for watching.